ever click on an app icon and just expect it to work?
Happens all the time.
Or maybe the opposite happens, right? And you're just left staring at that spinning wheel of frustration.
Ugh, yeah. We've all been there.
Today, we're going to peel back the layers on that whole experience. We're diving deep into application testing based on some really insightful notes we've got. Think of it like the high-stakes detective work that happens before an app ever lands on your phone.
Yeah, that's a good way to put it.
All to make sure it's actually, reliable.
That's a perfect way to frame it, actually. Application testing is essentially this systematic investigation. It's about running a whole battery of tests across an entire application to uncover any errors that might be lurking beneath the surface.
Okay.
And the real win here is improving the overall quality of the software you use every day. Plus, cutting down on the costs of fixing problems after release.
Which must be huge.
Oh, yeah. Making sure the developer's hard work actually pays off, and ultimately sort of speeding up the delivery of solid, dependable apps.
Okay, so let's unpack this detective work a bit more, because it sounds like it's way more involved than just tapping a few buttons and, hoping for the best.
Oh, absolutely. Exactly. Our sources highlight a whole spectrum of testing. It's not just about whether that button works, that's the GUI, the graphical user interface, what you actually see. It's also about the underlying functionality, how the app actually does things. The database, where all the information is stored.
All the data.
Yeah, and even how it copes when, say, a huge number of people try to use it all at once. Load testing.
And this isn't just a quick check right before launch, is it? It sounds like it's baked in from the very start.
Precisely, yeah. Think of the testing lifecycle as running parallel to the entire software development process. It kicks off right when they're figuring out what the software even needs to do, this requirement analysis.
Okay, right at the beginning.
Then comes test planning, where they map out their whole testing strategy.
Yeah.
After that, test cases are designed. These are the specific scenarios they'll test out.
Like step by step.
Exactly. Then comes the actual execution, running those tests. And crucially, when something goes wrong, there's bug reporting.
Right. Got to track those bugs.
So yeah, this isn't a quick once-over. It's an ongoing process. It's really fundamental to making sure the digital tools we rely on actually deliver.
So, okay, when you have software with just tons of different features and processes, how do testers even begin to tackle that complexity? It sounds, well, frankly, overwhelming.
Yeah, it can be.
Yeah.
But what's fascinating here is the methodical approach they take. The notes outline a 4-stage lifecycle specifically for testing. First, they design test plans based directly on those initial application requirements.
Okay.
This is all about making sure the testing is laser focused on what the software is actually intended to achieve.
Right.
Imagine trying to find a specific missing ingredient in a huge pantry. You need a recipe, right? The requirements to guide your search, which is the test plan.
That makes sense. You really need to know what you're looking for before you start looking.
Absolutely. So the second stage is developing the tests themselves. This means creating very specific test cases, these detailed step-by-step instructions for testing a particular feature.
Okay.
They might also write automated scripts. These are essentially bits of code that can run tests automatically, which saves a lot of time and effort.
Automation makes sense.
Yeah. So these can be manual tests, where a tester physically goes through the steps, or automated, where software does the heavy lifting.
Right.
The third stage is executing those functional tests. This is where they actually check if the application does what it's supposed to. Does that submit button really submit the form?
Does the math add up in the shopping cart?
Exactly. Does the shopping cart correctly calculate the total? This is the real moment of truth for each individual feature.
Right. Does it actually work?
Precisely. And the fourth stage is all about performance. This involves running load tests to see how the application behaves when a large number of users are on it simultaneously or under a really heavy workload.
Like a Black Friday sale on a website?
Exactly like that. Load testing simulates that massive surge in traffic to identify any potential bottlenecks or crashes before they happen in the real world. Based on these tests, they then fine-tune the application's performance.
Okay.
So it's not just about whether it works, but how well it holds up under pressure.
Now, the type of app must make a huge difference in how you test it, surely. You don't test a website the same way you test, a phone app, do you?
Definitely not, no. Our source material neatly breaks down application testing into 3 main areas: web application testing, desktop application testing, and mobile application testing.
Okay.
Within each of these, there's a distinct set of testing types that are particularly relevant.
Okay, let's start with web applications, the things we use in a browser every day. What kind of testing goes on there? Seems pretty common.
Yeah, for web applications, the testing landscape is actually quite comprehensive. Of course, you have your core functional testing, ensuring all the website features work as intended,
The basics.
and performance testing, checking its speed and stability. But then you also have cross-browser testing, which is vital.
Oh yeah, making sure it works on Chrome, Firefox, Safari.
Exactly. Making sure the website displays and functions correctly across all those different browsers. Load and stress testing, like we discussed, are about handling user volume.
Right.
Regression testing is crucial whenever changes are made to the site.
What's that exactly?
It ensures that new code hasn't inadvertently broken existing features, like making sure that fixing a bug in the checkout process doesn't suddenly mess up the user login.
Ah, okay. Makes sense. Don't break what's already working.
Precisely. Then there's compliance testing, checking if the website adheres to relevant regulations like accessibility standards or data privacy rules.
Important stuff. Yeah.
Very. User acceptance testing, or UAT, involves getting feedback from the actual intended users before a full launch. Beta testing releases a pre-release version to a wider audience for real-world feedback.
Okay.
Exploratory testing is a more free-form approach, where testers investigate the application without strict scripts, just sort of poking around.
Like being a curious user.
Kind of, yeah. Smoke testing is a quick initial check to see if the most critical functionalities are working. Like, does it even start up?
Gotcha. The basics.
And finally, multi-language and compatibility testing ensures the website works correctly in different languages and different environments, like operating systems.
Wow. That's a massive checklist just for loading up a web page. What about desktop applications then? The software you actually install on your computer. That feels like a different beast altogether.
It is, in some ways. Desktop application testing often focuses more on things like UI testing, how the user interface looks and behaves visually on the desktop itself. Usability testing is really key here, making sure the application is intuitive and easy for users to navigate on their computers.
Less about different browsers, more about the OS maybe.
Exactly. Performance testing is still important, but it's geared towards the desktop environment, how it uses local resources like your CPU and memory. Compatibility testing involves checking how the application works with various operating systems, maybe different versions of Windows or Mac OS, and hardware configurations.
Will it run on older machines?
Right. Will it run smoothly on both older and newer computers? And naturally, functional testing is still a core component, as is security testing, which is crucial for protecting the application and any user data stored locally on the machine.
And then we step into the world of mobile application testing, which I suspect has its own unique set of headaches.
You're absolutely spot on there. Mobile app testing shares some fundamental types like UI testing, what our source calls rule-based testing. Yeah, it's about ensuring the app adheres to platform-specific UI and UX guidelines, like Apple's Human Interface Guidelines or Google's Material Design Systems.
Ah, okay. Making it feel native to the platform.
Exactly. And you still have regression, functional, and security testing. But the mobile context just throws in a whole new set of variables.
Like what sort of specific things do they have to consider that aren't really an issue for web or desktop?
Well, the source material gives some great practical examples. They test the installation process itself, whether it's over-the-air, OTA from an app store, or maybe side-loaded via cable connection.
Right.
They look at connectivity. How does the app behave when switching between Wi-Fi, cellular data, maybe even Bluetooth? Does it handle losing connection gracefully?
Oh, good point.
And there's uninstallation. Does it clean up after itself properly?
Yeah.
The app's visual elements, like the logo on the splash screen when it starts up. How it handles low memory situations on a device. Does it crash or slow down?
Yeah, that's annoying.
Very. The visual feedback it provides to the user, and even the seemingly simple act of exiting and restarting the application. All those little details can significantly impact the user's experience on a mobile device.
It really is all those little things, isn't it, that can make an app feel polished or just completely frustrating.
Totally.
Now, the notes also mention different methodologies for testing. What are these strategies all about? Sounds a bit theoretical.
They're the different fundamental approaches, really. The ways testers try to ensure they achieve comprehensive test coverage. The notes highlight three main ones: black box, white box, and gray box testing.
Black box. Sounds intriguing, like you can't see inside.
Exactly. Think of it like testing a vending machine. You put your money in, You press the button for a snack, and you see if you get what you asked for.
Okay.
You don't need to know how the internal mechanisms of the machine work, the levers, the spirals, to test if it's dispensing the right item. That's the essence of black box testing.
So just testing the inputs and outputs.
Precisely. It focuses solely on the functionality of the application, from the end user's perspective. Testers interact with the software's interface and evaluate whether it produces the expected outputs for given inputs, without any insight into its underlying code structure.
Right.
The source mentions it's commonly used for functional, non-functional, and regression testing. And within black box, there are specific techniques,
Like what?
like equivalence class testing, where you group similar inputs that are likely to behave the same way and then just test one input from each group. Saves time.
Smart.
Boundary value testing focuses on testing at the edges of those input ranges. For example, if a field accepts numbers between 1 and 100, you definitely test 1, 100, maybe 0, 101.
The extreme.
Exactly, the boundaries. Decision table testing is used for applications with complex if-then-else logic, and state transition tables map out the different states an application can be in and how it moves between them.
Like the stages of an online order.
Perfect example, from adding to cart, to payment, to confirmation testing those transitions.
Okay, so black box is all about what the user sees and experiences. What about white box testing then? Does that mean you do look inside?
You got it. White box testing is all about examining the internal workings of the software, its code structure, design, and logic. Testers here actually have access to the source code.
Okay, so they need to be able to read code.
Typically, yes. They aim to identify issues that might not be apparent just from using the interface. Things like internal security vulnerabilities, broken or inefficient paths in the code, problems with loops or conditional statements, stuff hidden deep inside.
So what are the strategies there?
Well, strategies used in white box testing include code coverage analysis. This measures how much of the application's code is actually executed during the testing process.
So you know if you missed testing some parts.
Exactly. Low code coverage could indicate that certain parts of the code haven't been adequately tested. Path coverage is another technique that tries to ensure all possible logical paths through the code are tested at least once. Think of it like a mechanic examining the engine of a car, looking at all the components, not just taking it for a test drive.
Right. Okay, so black box is user-focused, white box is code-focused. What then is gray box testing, it sounds like? A bit of both.
That's precisely it. Gray box testing is a hybrid approach. It combines elements of both black box and white box.
How does that work in practice?
Testers using this method might have some limited knowledge of the application's internal workings. Maybe they have access to design documents or database schemas, but not necessarily the full source code.
Okay.
This limited knowledge allows them to design more effective black box tests, or maybe to better understand the root cause of issues they find during black box testing. The goal is often to uncover defects that relate to improper structure or how the application is being used in ways the developers perhaps didn't anticipate.
Finding those tricky edge cases.
Exactly.
This all sounds incredibly systematic. I'm guessing there must be some kind of master document that guides all this testing effort.
Absolutely. That's where the test plan comes in. Our notes really emphasize that a test plan document is absolutely crucial.
Okay.
And it's typically derived from foundational documents like the product description and the software requirement specification. Think of it as the project management document, specifically for the testing part of the project.
So what kind of essential information would you find laid out in a typical test plan?
Well, a well-defined test plan outlines several key aspects. It clearly defines the scope of testing, what specific parts of the application will be tested, and just as importantly, what won't be.
To know the boundaries?
Definitely. It states the objective of the testing. What are we trying to achieve with this testing effort? It details the overall approach for testing activities, what methodologies, what types of testing will be employed. It includes a schedule for all the different testing phases, milestones, and very importantly, it describes the process for bug tracking and reporting.
How bugs get logged and fixed.
It's exactly. How will defects be documented, prioritized, assigned, and communicated back to the development team? The test plan serves as a vital communication tool, making sure everyone involved, testers, developers, managers, understands the testing strategy.
It sounds like having the right tools for the job is also pretty critical in application testing. You can't just do all this manually, can you?
Well, you could, but it would be incredibly inefficient for complex apps. So yes, indeed. The notes mention that there's a wide array of testing tools available.
Okay.
And the specific tools you choose often depend heavily on the type of testing you need to perform functional, performance, security, and the platform you're working with, web, desktop, mobile.
Right.
These tools are designed to automate tasks, manage test cases, simulate user behavior, track results, and ultimately help ensure the performance, usability, and functionality of applications across all those different devices and environments.
Can you give us a few concrete examples of these tools? What names might people hear?
Sure. For automating web browser interactions, which is a huge part of web testing, Selenium is a very popular open source tool,
Yeah.
widely used.
Okay, Selenium.
Then you have commercial options like IBM Rational Robot and Rational Functional Tester, or RFT. These often offer a broader range of features, sometimes integrated suites.
Right.
For performance testing, LoadRunner, which I think is now called HP Performance Tester, and the open source Apache JMeter, are widely used to simulate large numbers of users and identify performance bottlenecks.
Simulating that Black Friday rush again.
Exactly. And these are just a few examples, really, from a vast ecosystem of specialized tools. There are tools for API testing, security scanning, mobile device emulation, each designed to tackle different aspects of the testing process.
Okay, so we've covered the why, the how, the different kinds of testing, the strategies like black box and white box, the importance of planning with a test plan, and some of the tools involved. What are some of the fundamental best practices, the things that help ensure all this testing is actually effective in catching bugs?
Yeah, there are definitely some key best practices that the notes highlight. One crucial practice is to clearly define functional specifications right at the outset. Having clear requirements makes testing much easier.
Garbage in, garbage out, basically.
Sort of, yeah. If the specs are vague, the tests will be too. Regularly conducting reviews and inspections of test plans and test cases themselves is also vital.
Getting a second pair of eyes.
Exactly. Catching potential flaws or omissions early in the testing process before you waste time executing bad tests. Establishing formal entry and exit criteria for each phase of testing is another one.
What does that mean?
It means defining clear conditions for when a testing phase can begin, like the code needs to be stable enough and when it can be considered complete, maybe a certain percentage of tests passed or all critical bugs fixed. It adds structure.
Okay.
Creating a diverse range of functional test variations helps to cover different user scenarios and those tricky edge cases we mentioned. For applications that need to work across multiple platforms or browsers, rigorous multi-platform testing is obviously essential.
Can't just test on one browser.
Absolutely not. And finally, leveraging automated test execution wherever feasible can significantly boost efficiency and test coverage, especially for repetitive tasks like regression testing.
Running the same tests over and over after changes.
Right. Adhering to these best practices helps testing teams detect more errors more effectively and, hopefully, in a more timely manner.
But despite all this rigorous planning and these best practices, it sounds like application testing isn't always a walk in the park. What are some of the common hurdles or challenges that testers often face?
Oh, definitely not a walk in the park. The notes touch on some very real-world challenges. One frequent issue is that sometimes subtle problems only emerge when actual end users start interacting with the application.
In ways you didn't expect.
Exactly. In unexpected ways, in their own unique environments, different network conditions, weird hardware,
Yeah.
things you just can't replicate perfectly in a lab.
Right.
Another challenge is the inherent difficulty in always predicting the cascading impact, the ripple effect, that a seemingly small change in one part of the software might have on completely different, unrelated areas.
Fix one thing, break another.
The classic scenario. Testers can also struggle with a lack of clear visibility into application and operational errors sometimes. Makes diagnosing the root cause of problems a significant hurdle.
Like trying to debug a black box almost.
Sometimes, yeah. And let's not overlook the simple fact that thorough, comprehensive testing can be an incredibly time-consuming process, especially for complex, large-scale applications. There's always pressure to go faster.
Time pressure is always a factor.
Always.
Now let's loop back to mobile apps for just a moment. You mentioned earlier it has its own unique challenges. What makes testing mobile applications particularly tricky compared to web or desktop?
Yeah, mobile app testing, while built on similar principles, definitely comes with its own distinct set of complexities. Our source points out that with the sheer number of mobile users globally and the incredibly diverse range of devices they use.
iPhones, Androids, different sizes, old ones, new ones.
Exactly. Achieving truly comprehensive test coverage becomes a monumental task. The fragmentation of the mobile ecosystem is a huge one.
Fragmentation.
Yeah, the vast array of different operating system versions. Think of all the different versions of Android still out there, plus iOS versions. Then you have various processors, different amounts of memory, screen resolutions. It presents a massive challenge.
Testing on all of them seems impossible.
It practically is. So you have to prioritize smartly. Sometimes, development teams lack well-defined test plans, specifically tailored for the mobile context, which doesn't help.
Right.
The constant pressure to release apps quickly, get updates out, often imposes really tight time constraints on testing efforts.
Rush jobs.
Can be. Access to a representative selection of physical mobile devices for testing can also be logistically difficult and expensive.
Yeah.
You can use emulators, but it's not always the same as a real device.
Yeah.
And finally, just the sheer diversity in platforms and operating systems means testers have to account for a much wider range of potential issues than maybe on desktop.
It sounds like a constant juggling act, really, trying to cover as many bases as possible with limited time and resources.
That's a very good description of it.
So bringing all of this together then, what's the core takeaway message about application testing? What's the one thing we should really keep in mind?
I think the fundamental purpose, as our source really underscores, is to ensure that the entire application undergoes thorough scrutiny, not just bits and pieces.
The whole thing.
The whole thing. This involves employing a diverse toolkit of approaches, from evaluating user-facing functionality, the black box view, to examining the underlying code, the white box view. It means utilizing specialized tools to automate and manage the testing process efficiently, and adhering to well-defined methodologies to guarantee comprehensive coverage as much as possible. Ultimately, application testing plays an absolutely vital role in the success of any software product. It's about identifying and rectifying issues before they reach you, the end users, ensuring a higher quality, more reliable, and hopefully less frustrating experience.
So to wrap up this deep dive, it's really clear that the seemingly simple act of, just using an app on your phone or browsing a website involves a huge amount of unseen effort.
A massive amount.
There's this meticulous planning, a wide range of testing techniques, specialized tools, all working in concert behind the scenes to deliver software that, well, hopefully just works.
Exactly. It's a constantly evolving and multifaceted discipline, and it's absolutely essential for navigating the increasingly complex digital world we all live in now.
So here's a final thought for you listening. Consider the last time you encountered a really frustrating bug in an app. Maybe it crashed right when you needed it, or a key feature just completely refused to work.
We've all been.
Yeah. Now, having gained some insight into all these intricacies of application testing, what kind of challenges do you think the testers might have faced in trying to prevent that specific issue? Was it fragmentation? Time pressure? A weird edge case? And what does this maybe tell you about the ever-evolving and sometimes, let's face it, delicate relationship between us, the users, and the software we increasingly rely on every single day? It's definitely something to ponder.
CTSS Academy.